If you do this correctly, okay, just enter this into your L1. I would sort it if I were you, but the first thing is mean, standard deviation. That's what I need here. I didn't ask you for n, so technically just that. So the way I would mark this is 1 mark for the correct mean, and I would give you half a mark for the standard deviation regardless, because you probably typed in a wrong number or something if it's off. So you don't lose any more marks. Once this is off here, you lose 1 mark, but then I won't take off more marks down the road. I will honor your work. So given that my mean is 2.51 and my standard deviation 0.56, I go up, actually I go up 4, but you didn't need to. It's just up 3, down 3. And then looking at your sorted list, you start putting the values inside the bin that they belong to. This is what you should have, like 1, 5, 13, 8, 7, and 1. And if you did the work here, based on your previous mean and standard deviation, you still get the marks here, even if the numbers are off. But you do lose a full mark at the very beginning, right? So you got to make sure you're careful with that. Then I ask, is data normally distributed? So if you go within 1 standard deviation, that would be 13 and 8 out of the 35, right? It ends up being 60%. So technically you can stop there and say data is not normally distributed, since data does not follow the 68, 95, 99.7 rule. I made a check. I kept checking. I was okay with the 2 standard deviation and the 3. I was okay there, but the first one didn't jive, right? Didn't follow. So you just have to make this statement here. I would say that is a full mark, and actually checking within 1 standard deviation, getting that 60% is another mark. Okay. So again, because you need to know how to do this, right? 1 standard deviation, 13 and 8. Then 2 standard deviations, like you actually add 4 bins worth of values together. Okay, and then 3 standard deviations, there should be 6 bins that you add up all of these values and compare them to the 35 that you've collected. Okay. Next, for this question, this should be a non-issue, hopefully at this point. When you have a frequency table where there's a range, you need to find the midpoints. That is worth a mark. Okay, so there are your midpoints. You need to put those in L1 and then the frequency in L2. And you get your mean, your standard deviation, and n. N is 184 salaries, right? That's what it represents if I were to ask you. So that's what I'm looking for there. So you get 1 mark for the midpoints and just 1 mark collectively for coming up with that information. Because really it's just type it in and go, right? If you did not use L1 and L2, you probably got 40,000 as your average. And n is equal to 8. That's how I know, right? Like you made a mistake. You did not include all 184 salaries. Okay? 7 marks for this page. Backside. I'll just go over it with you guys. Cover this up for now. The backside, right? We're told that the life of a lifespan of TVs have a life expectancy of 10 years on average, standard deviation of 115. Use technology to answer. If I give you a bell curve, it's just to help you out. But because it's probability, we're asking for percentage, and you want TVs that last less than 7.5, right? So there's an indication that you want to go negative, that's your low, up to 7.5, followed by mean and the standard deviation. So you should get 1.49%, okay, if you did that right. So 1 mark for that. I need to see this entry. If you just come up with 1.49, I will question that, right? Like, you need to show me the work there. This one is a little tricky, but it says what percent of TVs last less than 9 or more than 11.6 years. So watch what I did. I found out everything from 9 to 11.6. Like, I found that out, and that is this chunk right here that I don't want. We really want all the TVs that are less than 9 or more than 11.6, right? So the tails of that curve. So I find this, that would be worth a mark, finding in between. And then I go 1 minus that part that I found to leave me with 27.43%. Okay, that's worth another mark there. If you figured out, if you did a normal CDF and found out this tail and another normal CDF to find that tail, and then you added them, that is fine as well. You should get the same answer. Okay? Does that make sense? Yeah? Again, I go indirect. I subtract from one what I don't want, leaving me the tails. But you could also find the tails, add them up. That's direct reasoning. Okay? About 32% of TVs last less than this many years, right? So I give you percent, you want inverse norm, and it says last less than this many years, right? So the 32% is indicating you that it is to the left of the value we're interested in, and so that's 9.46 years if you did that correctly. Okay? Again, if you need a bit of a bell curve to help you out, you're like, okay, I'm asking for this X value where 32% lasts less than it. So it makes sense that you're somewhere over here. That gives you 32%, which would make the 68% that lasts longer. Right? Next, the top 12% of TVs last longer than this. Top 12. That is an indicator that I'm giving you whatever is to the right, and if it's top, you're further up the x-axis, which means this is 88%. So you having that 88% or the 0.88 is worth 1 mark, and then using inverse norm to figure out the number of years is worth another mark. That's how I come up with 2 marks. So if you used inverse norm, you get 1 mark for sure. If you use the 12%, then you lose a mark for using 12, okay? If 200,000 TVs have been produced, how many would last longer than 12.35 years? Okay, this is asking for how many. So basically I go 200,000 times normal CDF, because that's going to give me the percentage of TVs that we're talking about that last longer. So 12.35 is your low. This could have been a million, right? I used 10,000, but a million is probably even better. Just use a really large number, mean standard deviation. Okay, so you get a mark for figuring out the percentage, which is 0.0, well, this is not percentage, it's a decimal, but it's 2.05% approximately. You get a mark for this. And then the second mark is for you multiplying the number of TVs times that decimal. And you have to have a whole number there. So it's approximately 4,100 TVs. So 1 mark for getting the number, another mark for figuring out the percentage of TVs that last longer. Next, the middle 50% of TVs last between this and this many years. We did a couple of these already. So the middle 50, that means that the 50 is right in the middle. You have equal amount to either side of the 50. Right? So 50 is in the middle, then 50 is between these two tails. I split it equally into 25. Okay? So to figure out the first X value, I know that this is 25% to the left of that X value I'm interested in. So it's inverse norm, 0.25 followed by the mean and the standard deviation, right? That's 9.22 years. For the second inverse norm, that second x value, I know it's 50 plus another 25. So 75%. So to get that one is another 1 marker. So 2 marks for that. If you did a little bit of work on the bell curve, but you just didn't get this, I would give you half at least, right? For having tried it, having attempted that question. And last but not least, this is what the mini lesson I gave you today, right? So Gabriel and Jordan, they're both in physics, but they have different classes, different averages, different standard deviations. So the key here, or one of the strategies, is to find the z-scores, right? So Gabriel has a z-score of 1.56, you get a mark for that. Jordan has a z-score of negative 0.14, you get a mark for that. But then you have to tell me who did better overall, and Gabriel did, because Gabriel has the highest z-score. So when it comes to scores, the higher your z-score, the better you've done, comparatively speaking. So this page is worth 13. So add up the 13, and what was the front? 7? I should have made today's AC out of 67, right? That's what I should have done. 13 and 7, that's 20. So if you're still copying the back, if you want to copy what is in the back here, I'm going to zoom out as much as I can for that bottom part. If you need to do that, you go for it.